the kind of gotchas and things you want to know when you're auditing Cairo code or looking at Cairo vulnerabilities. We're not going to be really teaching you Cairo. I could spend an entire hour just teaching you Cairo, and probably more, and not get very far. So what I actually want to focus on is differences from Solidity and Rust, right? Cairo was inspired by both languages, so that's an interesting kind of jump-off point. I want to focus on Cairo-specific vulnerabilities. I want to focus on kind of merging standards and conventions in the space, obviously an important part of any audit. I also want to focus on kind of gaps in the security stack, right? And how that may inform, what tools you use, but then also where teams are more likely to have issues, where you need to spend more time to kind of cover those gaps as the ecosystem is quite early. I think in terms of if you're new to Cairo, the best way to use this presentation is probably go through it. Hopefully it sparks some interest in Cairo. Then go back and read the Cairo book, read the Starknet book, learn the language, and then come back when you're actually doing an audit. And I think you'll find this even more valuable the second time you go through it. So yeah, welcome to the Wild West. I've been working on Cairo code since December 2021. Back then, it was even crazier than it is now. To give you some perspective, we didn't even have block timestamps and block numbers. So one of the first things I did was write a L1 to L2 messenger oracle that would provide me a timestamp value that would be increasing over time. So it's a lot better now. And some of the things that built on Cairo is Yagi, which is a keeper network, and also some yield aggregator vaults on top of different Cairo protocols. So I've touched a bit of the kind of backend infrastructure stack, and also
excuse me, Peter.
Right,
just
smart
sort of
contracts.
interrupting.
Yeah.
Are you changing the screens? Are there supposed to be?
Yes, I am.
Okay, we only see the Cairo seminar with Spearbit, the first screen.
Oh, okay. Let me try and reshare it. Right.
Yes.
Is this better?
Perfect. Apologies.
Oh no, perfect. Thanks for pointing that out. Cool. All right. Yeah. So differences from Solidity and Rust, Cairo-specific vulnerabilities, emerging standards, gaps in the security stack. All right. So yeah, I am the founder of Aera Finance. I built a couple of things in Cairo. You can also check out Awesome Cairo, which is a GitHub repository I maintain with kind of different Cairo resources. Okay, so Starknet is thriving. It's a great time to look more into the language. This recent announcement basically is Starknet open sourcing the prover, which was kind of one of the final pieces of infrastructure that was really kept secret from the public. And that actually basically makes the kind of whole infrastructure set of Starknet pretty much open source pretty soon. And also actually we're in a place where a lot of those different components, including provers, have already various alternatives implementations. So it's a great time to look at Cairo. In terms of the overall Starknet stack and types of applications you may come across in an audit, I'd say most of them fall into two buckets. One is DeFi, one is gaming. You'll obviously see also NFT apps and so on. These are kind of major focus areas. DeFi protocols, very similar to DeFi protocols you may see on other networks with some experimentation, namely in the areas of DEXs, oracles, and so on. And then we see a lot of gaming. And I think it's really the gaming side where Starknet is kind of running away from its peers. There's some really, really cool stuff. Kind of more niche areas that are also interesting are on-chain machine learning. So we'll look a bit about at that today as well. So why does Cairo exist in the first place? Well, there's a famous saying that the definition of insanity is doing the same thing over and over and expecting different results. And I think that applies to the L2 landscape today. Why is every single L2 trying to work with EVM and Solidity? This is an exaggeration. They obviously have good reasons. Compatibility is important. But Cairo is different for kind of two main reasons and in two main ways. One is the underlying virtual machine that Cairo uses is meant to prove programs rather than execute them. And specifically, it's using the Stark proving system. And then they're also different from an ergonomics perspective. And as we'll see, Cairo really tries to be a much more high-level language and tries to really take some learnings on from Solidity and Viper and some of the other languages that have preceded it. In kind of Cairo at a glance, it's really a general purpose provable language. So you can use it to prove, a lot of different circuits. The most common use case, and one we'll focus on today, is using it for smart contracts on Starknet. But just keep in mind that it's perfectly valuable and actually was first developed as a more general purpose proving language that can be used for client-side proving and other types of use cases. So it's very high level. It has custom types, generic linear types, some of the features that we don't really see often in smart contract languages, but are really exciting. It also has a multi-level compiler. We'll talk about some of those components later. It leverages non-determinism. Again, cover that soon. And then it has an immutable memory model. And we'll see some examples on how that plays out because it's really interesting. But it really allows Cairo to be very efficient under the hood, but in a way that doesn't interfere with the user experience of using it. Okay, so you may have heard kind of three versions of Cairo being thrown around: Cairo 0, Cairo 1, Cairo 2. Just to quickly clarify these, Cairo 0 was the original language. It was incredibly low level. And it was initially developed just to simplify the development of circuits that was done more manually. And it was kind of a Python meets Yule scenario, where it was very low level with some high level constructs. Later last year, Starknet developed Cairo 1. And that was a massive rewrite. And it was a rewrite that really took a lot of inspiration from Rust, both in the syntax and also the infrastructure stack. And really is kind of 99% of what the language looks like today is shaped by that kind of big rewrite. And we have this third version, Cairo 2, which came out really recently, which really mainly is Cairo 1, but with some changes in terms of the contract syntax. So for the purposes of this particular seminar, we'll just focus on Cairo 2. But in terms of code out there, there's still applications that are running on Cairo 0 and Cairo 1 as well. So we'll cover a bit of some nuances and differences between them as we go along. But I wanted to make this as future-proof as possible. So if you want to play along, version 2.1.1 is what I've used for some of the snippets in this seminar. All right, so here's the plan. We'll do 5 things. And really, this presentation is not going to be about going in massive depth on one specific big vulnerability. We're actually going to do the opposite. We're going to look at a very broad range of vulnerabilities that hopefully are going to give you some intuition to Cairo, and also not going to be too tiring or difficult to grok. So we'll cover kind of 5 big categories that may come up in an audit. So one is the kind of core language and core primitives. The second one is the contract syntax. Third one is standards. The fourth one is kind of different security factors. And the fifth one is security tools. So let's start with the language. One simple way of thinking about Cairo is that everything is a serialized felt. So let me explain those 2 terms. So felt is what we call a field element in Cairo. The basic data type in Cairo, again, because we're really proving programs, we're not executing programs. Our basic data type is different what we have in Solidity. So we're using something called a field element. And we'll talk about its size and nuances before. And then everything else in Cairo is basically built up of these field elements. So when we have different types of custom data types and so on, really the way we think about interpreting those data types is through serialization, deserialization from the field element data type. And so we'll talk through some examples on how you can start customizing things in Cairo and where bugs happen. And it's, the best way to understand it usually is like, okay, how many felts are there actually? How are things being serialized, deserialized? Help you understand most of what's going on. And this is true for custom data types. This is true for storage that's being written to. And this is true for things like function arguments and ABIs and so on. It all maps down to felts. So obviously the first place to look is, what are these felts and how do they work? So the key idea here that every value in this default data type is effectively in this range from 0 to P exclusive, where P is a large number that is slightly less than 2 to the power 252. And that's why this felt data type is, in the language, for better or worse, referred to as felt 252. And the idea here is that we're operating, for some of you who may know a bit of math, we're operating in a field of that size. So that means that we have defined kind of addition, multiplication, and different types of mathematical operations in that field. And sort of the difference between what you may expect is really in all these operations happen modulo that prime, right? So if we're adding things together, we're adding things together and then taking the remainder dividing by P. If we're multiplying things together, we're taking the product and then taking the remainder dividing by P. So let's look at one particular example. Here we have a very big number, A. We take the square of that number, and then what we get is 1 as a result. So couple of things to note here. So one thing that is immediately interesting is that we have overflowed, right? The product of two is bigger than each number individually, and also there has been no panic or any type of revert happening here. So important important vulnerabilities to know. There's no kind of safe math or any type of checking for field elements. They work in this modulo kind of fashion. Where it gets interesting is when we start, and actually addition, subtraction kind of will work in the way you generally expect. But where it gets interesting is that division is not even kind of defined by default. And you will not get the answer that you expect, which is kind of 1. 3 divided by 2, rounding down, you would expect 1 here. And the reason is that field elements kind of don't follow your usual binary arithmetic that you expect. And actually, if we wanted to compute this answer here, the correct way to do it would be to take 3, then take the modular inverse of 2, and then multiply them together. I don't want to dive too deep into this. There's great resources online, but to give you some sense of modular inverse is basically whichever number you have to multiply by 2 to get 1. When you're dividing by the remainder, taking the remainder, dividing by p. So, for example, if p was just 7, then the modular inverse of 3 would be 5, because 3 times 5 is 15, and then dividing by 7, you get the remainder of 1. So, yeah, this is an important quirk, but the good thing is you don't always have to worry about this because, as I discussed before, everything is built on felts, and we do have kind of higher level data types in Cairo. So we have these kind of unsigned integer data types you can use. This, for example, is the 128-bit type, and that beautifully also comes with checked math. So now, if we're trying to subtract 2 from 1, we're going to get a panic. So integer types are usually safer and kind of what you use for basic arithmetic. Okay, so another way we use felts is with short strings. So out of the box, Cairo doesn't support strings. And here's another thing that you have to be careful with. You can use these kind of literals. So in this case, if you use a short literal, test, very short word, that's fine. If you use a longer description, that's not okay because it just doesn't fit in a felt. So be very careful about this. There's really no, I think, standard string library as I'm aware as of yet, but it's something that people are developing and likely will end up in the language at some point. Right now, yeah, don't use it for long descriptions and so on. Cairo is also block-based, and this may trip up people who are used to looking at Solidity. It works much more like Rust in this instance. So specifically, let's look at this function block fn. In this function, we assign the return value to 7, and I've named this variable very provocatively. And then we have an if statement. So if we just were to glance over this code, maybe with the eyes of a Solidity developer, our instinct would be like, okay, well, we don't see a return statement. Maybe the value is being assigned, the return value is being assigned earlier on, so maybe it's actually 7. But no, what actually is happening here is that Cairo is a block-based language. So the return value of a block is usually the last expression in that block. So the last expression of this function is the if statement. And then we can do this recursively as well. So the if statement has 2 branches. Each of them is a block. So whichever branch triggers, the last expression in that block will be the return value of the whole block. So if we look at the test case below, we can see that if we pass in 1, we get 0. And then if we pass in 10, we get 1. Another important detail is this notion of immutability and how it actually plays out, and that you have to be very careful with variable assignment. So let's look at these scopes in the first function. So this function basically tries to just sum these three numbers together and get the total. So we first assign the first number, and then we check if the other 2 numbers, if one of them is positive. If it is, we recompute the total, and then we try and return it. Unfortunately, this doesn't work. This returns only 7. It doesn't end up adding 3 and 5. Well, why is that the case? Well, what actually happens is that we are effectively relabeling what total means. We're not actually mutating that value in this inner block. And then as for the outer block, the value does not get overridden in any way. So now we end up just returning the original total value that we assigned. So just be very careful with block levels and shadowing. The correct way would be to declare a mutable variable. So in the second function, we declare a mutable variable called total. We assign earn there, and then we add the other 2 rewards on top of it. And this gives us the correct answer of 15. So this may confuse some of you, because I just told you that Cairo is built on immutable memory. And in fact, in previous versions of Cairo, namely Cairo 0, you really didn't have a way to do this. You really didn't have a way to elegantly, mutate variables. So how does this actually work? I just want to take a little bit of a detour here to explain this, because I think it is a beautiful concept, and hopefully will allow you to understand a lot of the rest of the language and how it can have this kind of very mutable memory system that has things like pointers and so on, but that really just works very differently than what you may expect, but then has a very kind of ergonomic and mutable looking language on top of it. And this diversion is going to start with functional programming. So the initial idea of immutability, I think, was really kind of gaining attention with Clojure. And so Clojure was this Lisp type functional language that had this idea that it's very unsafe to be able to mutate state. And so they came up with this idea of using, for example, a data structure like a set. And then if you're adding something to that set or adding something to an array, you would be creating basically a copy, a new immutable data structure, which will contain all the elements that were there before and then the new one. And this would be a much better interface for people to interact with programs, because all of a sudden they didn't have to reason about immutability. They were just creating copies of things. Well, the problem with that is that copies are really expensive, right? However, Rich Hickey found some research papers which describe these persistent data structures that actually solve this problem and made copying really cheap. So imagine this tree on the left is like some sort of set. And now we're basically adding only one extra element, and then we're adding some pointers that are telling us like, hey, this new set that's in red points to like a subset of this original set with some new element added. So the nice thing here is that we're basically able to copy very cheaply. We're only creating the elements that we need, and we're still able to point to the existing information that we had in existing data structures. How does this look in practice? Well, apologies here if you hate reading Lisp. I'll try and explain it very simply. So this first assignment here creates a set of 4 variables. Then it adds a 5th variable, and it creates a new set. And all of a sudden we see that there's 5 elements in the new set. However, now that we check the count of the original set, it's still 4 elements, right? So what we can see here is actually we had immutability. The original set did not change. We just simply created a copy very cheaply. And so this was like a very powerful thing. And for a while, people thought this is the best way to do immutability, until Rust came along and until the Immutable Crate came along, and I think showed us a very important lesson about immutability. So Rust created this Immutable Crate, which incorporated these same data structures, the same persistent data structures, but it implemented them in a very different way in terms of the actual interface. It had a mutable interface to these data structures. And in particular, they had a very important, if you read their documentation, it had a very important kind of explanation of this, right? So it said, while immutable data structures can be a game changer for other programming languages, the most obvious benefit is avoiding the accidental mutation of data, and is already handled so well by Rust type system that it's just not something a Rust programmer needs to worry about, even when using data structures that would send a Clojure programmer into a panic. Immutable data structures offer other benefits though, some of which are useful even in a language like Rust. The most prominent is structural sharing, which means that if 2 data structures are mostly copies of each other, most of the memory they take up will be shared between them. That's what we saw before, right? Most of the memory is kind of shared. So this implies that making copies of an immutable data structure is very cheap. It's really only a matter of copying a pointer and increasing a reference counter, where in the case of vector, which is Rust's kind of array type, you have to allocate the same amount of memory all over again and make a copy of every element it contains. So this idea here that, immutable data structures are really just ways of making copying efficient, but they shouldn't really change the interface. And actually, if we look at the interface for the Immutable Crate in Rust, we see that you can operate with these data structures in the same way that you would with mutable data structures. You wouldn't even know, right? You can declare this set, you can add some filter on this set, you get a new set back, and it seems like you've actually mutated it, but you haven't. So I think Cairo works in a very, very similar way. The underlying memory is immutable, but you have mutable handles over it. So it looks like you're using mutability. You get the ergonomics of mutability when you need to, but underneath you're not actually changing any values. Another kind of interesting thing is Cairo does have loops, and they can be infinite. So you have to be very careful. Again, in this case, this loop is vulnerable and is going to run out of gas, basically. Why? Well, let's look at it. So at first, we assign a variable called I. We make it mutable as we should, and we assign the value 0. Then we have a check. If I gets too big, we're just going to break out of the loop. And then we assign, we basically try to increment I by 1. But again, we're not actually incrementing anything, we're just reassigning. So this doesn't really work, and we get an out-of-guess exception. The correct thing would be to mutate that value. So something to be thinking about, Cairo is not like Viper in this case. You can get infinite loops, and you have to always break out of them. All right, so final pieces, and this may be a little bit tricky to people who are not familiar with Rust and borrowing. But if you understand this example, you will understand like the most complicated feature of Rust. And I think you will also understand one of the most complicated features of Cairo. So hopefully we can get this done in a short amount of time. All right, so let's look at this function on the left. So this is Rust code, by the way. This is not Cairo code. As you can see, it's like incredibly similar. So we first assign a mutable value, create a mutable variable called A, and we assign it to value 2. Then we create a new variable called B, and we do this weird ampersand thing. So what it actually means is we're borrowing the value of A. Then what we try to do is increase the value of A, and then we're trying to print out the value of B. Rust complains here. Rust is saying, well, you just borrowed A here, and then you're trying to assign to it, right? So borrowing kind of works just like in real life, where if you borrow something from someone, they don't have access to it at that point in time, so they can't obviously modify the thing you borrowed, right? If you borrow someone's car, they can't, change the wheels on that car, right? So Rust works the same way. Cairo has a very similar operator, and people always ask, like, why did Cairo just not use the ampersand? Like, why does it use this at? Why does it use this, what we call the snap operator? Well, because it actually works in a very different way. So first, this is basically an equivalent example in Cairo of the same code. We assign a mutable variable A, and we assign it to value 2. Then we take a snapshot of this value A. Then again, we attempt to increase the value of A by 1, and we print out the value of B. But this time, when we print it out, first of all, it doesn't complain, and second, it prints out the old value 2. So what happened here? So first of all, clearly we didn't get a reference to this variable, because if we did, then it would print out 3. Well, actually, what we got a snapshot of that variable at that point in time. And if you understand that Cairo has immutable memory, this actually starts to make sense, right? We took a snapshot at that point in time. We are basically pointing to that kind of immutable, slot in memory. When we increment the value of A, what it's really doing is kind of creating a new variable in memory, but it's not modifying the existing one. So we don't get the new value, we get the snapshot. So that's why it's different. That's why it's called snapshot. That's why it's not borrowing. However, this is obviously the most contorted example to try and show you the difference. A lot of times when it's actually used in practice, you do use it very similarly to how to use borrowing in Rust, where you don't try to take ownership of a variable when you don't need it to compute something. All right, so I think we had a question here about why doesn't Cairo immediately compute the modular inverse? And actually, kind of original versions of Cairo did do that. I'm sure it may be just an ergonomics thing in newer versions of Cairo, not to confuse people, to just not define that by default. But I'm sure there's a trait you can just import to make it work. And I thought this would be a wonderful opportunity to talk about how traits work in Cairo and why you should be very afraid of them. So let's look at this example. So again, this is the same example where we have A as 3 divided by 2. But now the value we get is 5. So how does that work? Well, this is the full code snippet. I actually hid this trait implementation up top. And in this trait implementation, I basically, this kind of works the same like operator overloading if you're not familiar with Rust. But basically I said, look, this is an implementation, felt 252 div of the division trait, which for the type felt, right? So I'm basically defining what division means for felt. And then I just define it to be addition instead of division. And it worked. And here's something that's very different again from Rust. In Rust, you can't really take an existing data type and just say, oh, I want to change how this works. No, you can't do that. In Rust, you have to wrap it in a new type, and then you are the creator of that new type, and you can define how that new type works. But you're not allowed to redefine existing types. In Cairo, you can actually do this. In Cairo, you can create trait implementations for types that somebody else defined. So when you're looking at something that seems very familiar to you, hey, I'm just seeing a bunch of felts being divided, or I'm seeing a bunch of UNs being added together, be incredibly careful and make sure you're aware what trait implementation is actually being used, whether it's an import that's being used from somewhere else, whether you have made that trait definition. You can't locally understand what a piece of code does without knowing the trait context of that. So I wanted to also talk a little bit about kind of higher level, kind of more complex data structures that are in Rust. Rust has arrays index. We'll look at arrays today. And I think they illustrate some interesting concepts. So arrays, you can think of them as kind of queues of values, right? So imagine we have this like long line of memory, right? Which is this mutable memory. So like, how would we build an array with that? Well, we would start with like one element, we would grab that. And then if we wanted to add another element, we would just take that. And if we wanted to add another element, we would just add that. And now we'd have 3, right? So what if we wanted to remove an element? Well, we can't remove it from the end, right? Because then we couldn't add the next one. But what we can do is we can like pop elements off the front. And so those are the 2 main operations that Cairo arrays actually support. They just really just work like these little kind of snake type queues that are just moving down the memory lane. And I think this is also a perfect opportunity to talk about kind of the difference between, panic and like what we think of as reverting, maybe in solidity, versus kind of returning an optional return type, which we're more familiar with in Rust. And in this case, we're creating an array, we're adding one element to it, and then we're popping 2 elements. The first call would succeed, the second call would return an option value of none. So basically, this is kind of similar to null in certain programming languages. Doesn't mean that this doesn't actually fail. It just means that it's failing gracefully in a way that you can, afterwards process this value, do a switch statement on it, effectively a pattern matching statement on it, and figure out how to deal with the error gracefully. So it's very nice. All right. So another kind of quirk with arrays is that dangling pointers still work if we remove a value that we previously snapshotted. So in this example, we create an array. We add 3 values, 1, 2, and 3, and then we have a match statement where we're trying to get the first value in the array. And actually, there's 2 functions. There's get and at. At will get the value. Get will get the pointer. So we're much more interested in get. And we will here go into the first branch. And the first branch says, if there is a value at the index 0, then let's just pop it off there. Let's just pop that first value off. And weirdly, the snapshot still works. So X is now pointing to this kind of snapshot of this first element. We can unbox it, print the value, and it prints the value 1. So again, maybe somewhat similar to this kind of the borrowing example I illustrated before. Once you take a snapshot of a piece of memory, that pointer, doesn't really get deallocated in the way you would traditionally think. It really is just a snapshot. All right, so that we made it through kind of the basics of the language. There's obviously more. There's kind of data types like structs and anonymous, but again, not teaching you Cairo. I'm just showing you the different ways that vulnerabilities can emerge in Cairo contracts and different ways that Solidity and Rust developers can really make the wrong assumptions about Cairo. And I think those are like great illustrations. So in terms of contracts, the thing that's kind of really different is this notion of a contract class. So contract instances are really separate from these classes. And this concept is related to a lot of ideas in the EVM, right? So one idea we have is this notion of upgradability. Well, this provides a natural path. We can upgrade a contract by changing its class. Another related idea is this idea of clones, right? We can use a clone from OpenZeppelin to basically deploy multiple versions of the same contract and be really efficient. We only need to, actually have implementation of that contract in one of the contracts, and then we can have, different contracts that are basically delegating to that. So, and then maybe a third idea is this kind of more recent proposal of a set code that would allow kind of similar type of upgrade that I described. Okay, so let's go through also a little bit of the contract syntax and some of the issues with that. So one simple idea is, this is an example of a two contract functions, right? So one would be setting, one would be getting. This contract is very, very clearly modifying state in the set function, and then it's getting kind of storage values read in the second function. But we have a view annotation. So what's happening here? Well, currently the Cairo compiler does not check whether view annotations are actually annotating functions that are not doing anything to storage. The function can really do whatever it wants. It can store data, it can call syscalls and so on. View annotations are basically now just for the developers and to mislead other people reading the code. So be very, very careful with annotations in the current state of the language. I'm sure they'll be fixed. Okay, another tricky one is the lack of a try and catch statement. So in this case, we have a contract that's trying to interact with another contract. And I don't want to get people to get bogged down in the syntax right now. Basically, when we think of Cairo contract syntax, it does have all the pieces that you would expect in Solidity. It does have storage, it does have events, it does have methods, it does have constructors. Those things are, however, implemented in a way that's kind of more elegant and kind of similar to Rust. So you have the kind of structs, which is your storage struct, and you have these different annotations to show what are events and so on. So this looks complex, but it's actually like really not that different from what you have in Solidity. So in this case, like we have this function that will call another contract. And so the problem is, what if this contract reverts? Well, currently there is no try catch, so we can't catch that revert. I think what we can do, however, is we could kind of go low level and use syscalls and try to understand what's happening. But yeah, something to think about in terms of like contracts that are higher level. Okay, this is another fun one that will probably trip up some of us that started with Solidity. Certainly tripped up me. So selectors for functions, right, when it comes to calling an external function, they don't actually incorporate the arguments of that function or the return values of that function, right? Function selectors get computed only based on the name of the function. So here we have this ABI where we have 4 functions that return kind of certain data types, and then we have the same ABI that is spoofed, and as you see, like these data types are actually very, very different. So we're spoofing the return type and actually changing it. So does this actually work? Well, yeah, in some cases it actually does. And this is really weird. So how does it work? Well, as I mentioned before, there's kind of 2 key principles in Cairo. Like one is everything is felts, and 2, everything is serialization, deserialization from felts. And that applies here as well. So when you think about calling another function in a different contract, if you are telling your own contract that you expect a certain value, then what you're basically saying is, hey, okay, call this contract, I expect this, and let's look at, for example, the last function, an array. So what it actually does is returns an array of felts, but then the spoofed version is basically saying, I only care about receiving 1 felt from that function. Here's what's actually going to happen. The original contract is going to execute. It's going to serialize the return value, and basically turn this array of felts into like still an array of felts effectively. It's basically everything ends up, again, as a series of felts, right, in serialized form. Now, your own contract is going to use its own API to say, I'm only expecting a single felt from this. So when I call this, I may get an array of felts, but I'm only going to pick the first one and then go with that. So that's really how you think about serialization, deserialization, and these spoof APIs. To the extent that your deserializer function is not going to revert, you can still basically try to use a different return value. But be super careful with this. Like there's some cases where this could be used for some form of gas optimization and so on. But again, something that you'd want to understand exactly how serialization, deserialization happens for both the contract that you're spoofing and then the signature that you're actually changing. Okay, so another one that is kind of similar is basically storage. Storage is not indexed by number; it's indexed by name. So this is a more contorted example. I don't want to go into too much detail, which shows how we can add our own, custom implementations for data types, how they can access storage. So if you invent a whole new data type, you get to define how it will be serialized and how it will be basically what its storage layout is going to be, right? So this is an example of that type of logic. Obviously, it can be very error prone. I'm sure a lot of auditing will be focused on these types of issues. But the one major thing not to trip up on is it's really not IDs, it's indexed by names, and then you kind of have a name offset, and you have actually something else called an address zone, which I'll talk about later as well. The general rule is, serialization, deserialization, try to use it wherever possible, right? So instead of using syscalls, which again, some of you may be very comfortable in like working in Yule and seeing Yule code. And the Cairo way is actually to try and avoid that as much as possible, to try and avoid syscalls as much as possible, and really focus on serialization and deserialization. So you can define serializing the Serde trait basically for any types you introduce, and then that will be applied in all these different contexts. Final one that is really scary is that in terms of that upgradability, any contract that kind of has a class hash can just replace the underlying class that it's using, right? So again, we have this notion of like a contract and then a class that it's using. the contract can just call this replace class syscall, and that would just replace the class, basically its implementation effectively. And you know, it doesn't have to have a lot of ceremony around it being an upgradable contract or not, right? It really just call this syscall and it's an upgradable contract all of a sudden. So the one thing you have to be careful here is that it's not going to invoke the constructor of that contract. It's literally just going to change the implementation. So yeah, have to be super careful. And again, like there's no easy way of knowing a contract's not upgradable. So you have to be really, you know, attentive to detail when looking at contracts and upgradability risk. And also, again, if you're using kind of, you know, I heard of a similar issue in the context of Dojo from Terrence, and he was talking about this issue they had around building a module system where users could add modules, and they really had to sandbox the functionality to make sure that users could not do things like this or modify state. So, yeah, very, very interesting one. And I think there's kind of more debate in an ERC right now happening very similarly. I think this is setcode ERC. About a similar feature potentially being added to the EVM. And I think same security concerns apply. And actually, Martin Trey from Open Zeppelin has been, helping with that and shaping that conversation. Okay, so another one is the L1, L2 messaging system. Of course, Cairo does have one. And, you know, as always, make sure you check the evaluator address and, you know, make sure it's not being spoofed and so on. So this is a typical one, probably not very unique to Cairo, but you know, something to I think illustrate how the messaging system works. Okay, Cairo uses native account abstraction kind of built in, right? There's really no notion of end user account in Cairo from day one. It's all account abstraction. So what that means is that there is a specific interface that all these account implementations should follow. And so kind of Starknet wallets like Argent and Bravos have their own account implementations that they use, and other types of applications, just, you know, gaming and so on, also create maybe custom accounts. You know, that one we'll be familiar with if you've studied ERC 4337. I think having this be more prevalent means that, you know, we should just be much more careful when looking at permissions. So for example, if you've played around with Frentech recently, you may have seen this kind of notion of arcade accounts, where accounts are being just spun up in the browser for you, and the private key is just sitting there, and you can just extract it if you want, but so can probably somebody else. And this is like one example of vulnerability that existed in a arcade wallet on a Starknet game that was found by Credence, and he kind of noticed that, hey, we were not we allowed the wallet itself to modify its public key, and we probably shouldn't be doing that. We probably should have a separate kind of designated role that's able to do that, because the wallet itself could be compromised. Somebody could get the private key. So at least we're not going to allow changing it. Okay, so we got through contracts. Third one is code standards. And this is, you know, if I talked about us being in the Wild West before, we are really in the Wild West now, because this is really, we're in a really early space. And it's a very confusing problem because, well, on one hand, we have all these kind of ERCs and learnings, and some of them are really useful. And then some of them are just that way because of how Solidity is and how the Ethereum virtual machine is. And so there's all this kind of compatibility question that we have, like, you know, should we just make the same mistakes just to be compatible? Should we try to move forward? And then the other world of influence is the whole Rust world, and that we have some kind of ZK concerns, right, around what's efficient for zero knowledge and what's kind of good intuition for provability, and how we should name kind of cryptographic functions and so on. And really, the current standards debate, I think, is very nascent. And it's nascent because there's all these competing concerns, and it's just a tough problem. So the community is still really figuring out these standards. So here are like some things that are evolving, though. One is, I think, we have this bedrock, which is the Open Zeppelin Cairo contracts. So your Open Zeppelin have been kindly building a series of really robust Cairo contracts that cover kind of all the typical areas you'd expect that they cover on Solidity as well. And so I think these are perfect examples, both of, you know, coding standards at the edge, right? They're not afraid to just like throw away folder names and completely change things. And they've been doing that since Cairo 0 and really shaping the conversation. And I think the community appreciates it. And also just providing a lot of default implementations that people can use safely. The more riskier trend is we also have a package manager, which is absolutely fantastic and is great to have a great package manager. However, obviously, we'll raise some security concerns and will be an important part of every audit, looking at really the dependencies and what it means to, you know, use the GitHub repos dependency and so on. Just to illustrate like the types of debates that we're having, it sounds all really cool, but, you know, sometimes we're just arguing about camel case versus snake case. Actually, we're kind of in a transition period. We've decided that snake case is the way to go because it's more like Rust. This was a very difficult conversation. But now contracts are in this intermediate stage where like they're promoting both interfaces. And that's best practice because we really had a mixture of people doing kind of ERC20 tokens with camel case and snake case, and that's obviously not very good. So right now we're in transition phase, and then we're going to kind of end up with pure snake case at some point down the road. Starknet also has Snips, which is arc-relevant ERCs. So for the types of things that Starknet needs a little bit of unique innovation on, there is a forum to discuss that, which I encourage you to check out if you're auditing code and want to refer to recent standards. And then there's just so much room for new conventions. I think we're really just figuring this out in real time. This is one from Ini. Like he was talking about introducing a convention for reading storage variables and then mutating them. So this particular convention talks about how if we read a storage variable, we should get a mutable handle, change it, and then write it back. And then if we are not trying to mutate a storage variable, we should not be getting a mutable handle. And the simple thing is kind of, maybe Cairo's version of the checks affects interactions pattern or some form of that, where, and I think there will be many more opportunities, right? The more high level the language is, the more we can use the type system to really document what's happening rather than just relying on comments. So I think this is a great example of that. Okay, so what are some other security factors? Well, Cairo is a multi-level compiler. So we have Cairo, which is rapidly changing. We have Sierra, which is a lot more stable, and Sierra is the intermediate representation. And then we have the Cairo assembly, which is like the lower level kind of ZK circuit kind of mapping. And so if you want to really understand what's happening in Cairo, I think a great place to look is Sierra. If you want to understand, catch compiler bugs or compiler issues or do gas optimization, I really encourage you to look into Sierra directly. So, but here are some other concerns that are interesting. One is this notion of hints, which you may have heard about in the context of Cairo 0. So, in Cairo, programs are proven by provers, and then those proofs are validated in a smart contract. So we can ask a prover to do work for us. So this is really like, imagine if you wanted to hypothetically get the square root of a number, right? We could write some complicated code to compute the square root of a number. And in Solidity, like that's kind of what we have to do. We could maybe ask for a built-in in Solidity, but asking for a built-in means like going through the standards process, proposing something, getting all the clients to upgrade. So it's not something that we'll just do very easily and very liberally. Cairo created this system called the hint system, where you could basically say, okay, I'll write some Python code that describes how to compute the square root of a number. And then I'm basically asking the prover, kind prover, here's a hint, run this computation to compute the square root and then plug it back into my program. Right? Do we see the issues with this? Obviously, the prover can just decide not to do this or like provide another type of value. So this is really dangerous. So the way to protect it is, well, if we have that square root value, let's just multiply it, just square it, right? And check that it matches the original number that we wanted to get the square root of. So that's really the general pattern with hints, right? You use a hint, but then you have some really super robust way of checking, and that's kind of what we're seeing here with a more complex hint, of checking that that hint is been executed correctly and it kind of satisfies some invariance. Right now, hints are not available for users of Cairo 2. They are used internally, and I think they will be made available for maybe other kind of client-side proving contexts. But they're, they exist. They are used for optimization. They're used for efficiency, and I think there'll be kind of great ways of like potentially building built-ins much more easily in the future. So good to be aware of. Another type of context you'll have to deal with as an auditor is, many apps are developing on layer 3s. In Starknet, there's pretty much like now a comprehensive stack of provers and sequencers that are being used to spun up L3s. So app chains are being developed. Apps are being developed on these app chains. So just to something to be aware of, and something that's very very like part of the Starknet fabric. And I think overall, the features I've described today, if you watch this presentation 3-6 months later. Some of them may already have been improved, and the reality is like this is only the beginning. So in particular, let's look at this storage read syscall. So this syscall describes how to access raw storage, and it's available to smart contracts to use directly. Well, it has this variable called the address domain, in addition to the storage address. Right now, the only the value 0 is supported. But in the future, this address domain will be extended to support different types of storage. And so one particular improvement coming to the Starknet network is this notion of data availability and having like different types of data availability standards. So maybe not saving things on chain, providing different options of storage. I think kind of similar to transient storage, for example, coming up in the EVM. And I'm sure this is not the last change, both in terms of the economics of the language, but also in the underlying network. Okay, so finally, what are some good security tooling that you can use? There are things that can help you with Cairo. So the two main Cairo frameworks are Scarb, the original one, and then Cairo Foundry, which is much more like a Foundry-like version of that. I think both of these are fantastic frameworks to use, and they have like testing and so on. And actually, you may find them incredibly fast. Cairo, because it's built on Rust, it really has an incredibly fast kind of runtime. And actually, it's being even improved by creating a kind of MLIR compiler that compiles Cairo to native code. So I think we'll see a world where running a Cairo program locally and testing it will be as fast as, nearly as fast as hopefully running like a Python program or a Rust program, which is very, very exciting. However, I think one of the caveats is, these testing frameworks are so early, they don't support things like fork tests. So as an auditor, this probably will freak you out a little bit, right? How do you build a protocol that interacts with other protocols without running fork tests? Well, unfortunately, it's just not something we can do today. So you just have to use, testnet much more intensely and be much more careful about protocols. It's just really hard to build protocols that are using other protocols today. Use Sierra, to understand how Cairo works behind the scenes, and specifically for gas optimization. Again, not enough time to cover that today, but gas optimization is a whole other exciting dimension of Cairo programming. It's also very, very different. We have a static analyzer from Trailbits called Caracal. We have SameGrep rules. We have Thought, which is a disassembler and also has some port modification support. We have a Cairo Fuzzer. I think this is not yet available for Cairo 2, but coming soon. So a lot of tools to play with, and hopefully this gives you like some kind of brief overview of the types of different vulnerabilities you run into while programming in Cairo. I wanted to thank a lot of people who actually, from the Starknet community kindly provided me with either their audit reports, so I could try and find unique issues, or actually literally tell me, this is an issue that I think people will be interested in. And there's too many of them to thank individually, but I'm super, super grateful. And actually, thanks to them, I think today you hopefully learned something about Cairo. And I think we see some of them in this room as well, which is amazing. So, in terms of like taking next steps in the Cairo ecosystem, I recommend reading the Cairo programming language book. Actually, a lot of the snippets in this were adapted from the book. So thanks Ini and the team for that. And then also the Starknet book is a great starting point. Reading more about the network, behind Cairo. As for myself, I write Cairo snippets most days. So if you're interested in just like seeing how the language is being used dynamically in real time with games and DeFi, you can follow me on Twitter. And finally, there's some great resources. So these are kind of really cool repositories that you can check out. The first one, Alexandria, is a standard library. Kakarot is a ZK EVM built in entirely as a Cairo smart contract, which is insane. Then we have Dojo, which is a entity component system and game engine for building games on top of Cairo. We have Tsubasa, which is an entirely community-built game to illustrate kind of Dojo and the stack around it. And then we have Orion, which is on-chain ML. It's literally like a TensorFlow-style library where the developers are developing tensors and different types of linear algebra operations to do on-chain machine learning. So it's been I think it's testament to the language that we've had these like really high-level and deeply complex applications being experimented with at this level. And I think that will create an exciting landscape for auditors as well to try and like make sense of all of it. So yeah, thanks everyone. I think we can go to QA at this point. All right. So Fran's saying, is this prover working with hints to build stuff for us, such as a square root implementation, an SMT solver built in the compiler directly? Yeah, good question. Right. So there's no SMT solver. It's basically just executing Python. It's at least the way it worked in Cairo 0. I think there's ideas of potentially, again, allowing hints to be written in Rust. Everything is moving to Rust in the Cairo space as of right now. So it doesn't actually have to use SMT. It doesn't really have to solve anything in particular. The hint is actually just pure executional code, just a bunch of steps that the prover has to follow. Really is and I think it's not a feature that unfortunately is just available to anybody who's using Cairo 2. I think right now you can probably dig it out in the Cairo compiler. It's being used there at a lower level. But yeah, something that hopefully will resurface for kind of client-side proving and more advanced use cases. But in Cairo 0, you could play around with it. And actually, hints was, by the way, the way that the kind of original Cairo framework called Protostar built its kind of cheat codes, right? So if you're familiar with Foundry has all these cheat codes. Well, the original kind of frameworks used these hints to hack together some cheat codes, and you were able to kind of debug contracts, print out values and so on, basically using Python, using these hints. So I think it's quite handy, and I do wish it was brought back, at least for the benefit of this more local development and local development ergonomics. Is there something like Ethernaut for Cairo? Yeah, great question. So how does the Cairo security stack look today? Well, it's very early. So there's a Telegram group called Starknet security, which has a bunch of us. Feel free to ping me if you'd like to join, if you're interested in that. And we're starting to figure all this stuff out. There is initiatives from the Starknet Foundation to really put in place things like bug bounties, competitions, and so on. So I think right now when we're in a transition stage where there are a bunch of Cairo auditing firms, there's audits being happening. I think you can use existing platforms, like Immutify, hopefully to cover some Cairo code. And I think there's been bounties in the past. I don't think there have been any kind of really Cairo-specific platforms that have gone mainstream attention yet. I think the one I'd love to call out is Only Dust have been handing out a lot of Cairo bounties. And these, I think a lot of them have been really around development. But I think, some of them are going to be around security as well going forward. So Only Dust is a great place. If you want to do some incremental contributions to Cairo repositories, great place to look. Okay. Yeah, and I think Devnet, in terms of actual security challenges, I think there's quite a few, and thanks Devnet for sharing them. Okay. Nikita asks, okay, is it going to be the same Cairo language on L3s? Yes, I think so. May have some, I think the L3s honestly have the option of adapting it, right? Because they could ultimately use Sierra. I think as a starting point, probably few will choose to adapt Cairo because they're maybe looking for kind of specific types of kind of linear speedups. But I think as L3s get more nuanced, right, we may get some L3s that really want to work around privacy, and they may find like they want to modify the language or create a new type of language, and I think they will be able to do that, right? They could just use Sierra, create another language that compiles to Sierra. So they're not like required to use Cairo, but I think most will probably to start with. Should I care about proving and other ZK stuff in Cairo 1 and 2, or should I just work with it as a programming language? This is a fantastic question. I think, personally, I'm kind of lazy, so I've honestly had a great time just using it as a normal language, and then when you run into things that confuse you, like these snapshots or how felts work, that's when you kind of can dig in and learn more about what's happening under the hood. I think for security auditors, unavoidably, you will have to learn more about these types of kind of lower level details. But as a programmer, you really, really don't have to. You can get away with building smart contracts that you see every day on Solidity in Cairo without understanding anything about ZK. Other than maybe some of these differences is really what's more important. So decoding the return value of a contract call, how it works, no type checks. So I think I talked a bit about this decoder. So from my understanding, and there's a great article, if you look at the chiropractic blog, Milan Cermak wrote this blog post where he went over this like spoofing example in much more detail than I could now. But I think the way it works is that type checking only really happens at the compiler. So type checking, in terms of these like high level types, these generics and so on, they really happen at the compiler. And then once we end up with Cairo bytecode, really what we are doing is we're kind of serializing and deserializing these values. So at that point, I guess it's a form of type checking, but it's not strictly speaking type checking. And I think you can understand whether the return value of a contract call will fail or not based on just looking at the deserialization or the serialization method for it. and like imagining what happens if like you get 3 felts and then like these 3 felts just as an array get inputted, like that's going to give you the semantics of that. How Starknet implements things like message senders, syscalls, built-ins, libfuncts. Yeah, so built-ins and libfuncts are really defined at the level of Sierra, and then they're just carried over to Cairo. This is not enough time to go into detail of like how these ZK built-ins work. They're actually there's a bunch of them that actually we don't even need to write. You know, if you look at Cairo 0, we had to like do all these additional kind of built-ins and circuits that have to be provided to do things like comparing numbers. Like if we wanted to compare numbers, we had to like add a specific circuit. If we wanted to store a number, we had to add a specific kind of built-in. All of that really happens at Sierra. So if you, I have written, you know, a partial Sierra documentation. So if you want to look into that for like the types of built-ins that are being used in Cairo, you can find that in the awesome Cairo repository as well. What are the tools for fork testing? So I don't think there are any. I don't think you can do fork testing right now in Cairo, but you know, I hope that somebody proves me wrong. Oh yeah, Amnes says like, does Devnet support for fork testing now? And we are working to add it to Foundry. Well, that's incredibly exciting. I think fork testing is one of the most important things we can do in terms of security. All right, is there something like EVM codes for Cairo? Yeah, low-level documentation. I haven't seen it. I think I've written partial Sierra documentation, as I said. I haven't seen anything similar for Cairo assembly. I think it'd be great if somebody took a stab at that. I'm sure that the Starknet community would support it. Why devs would pick Starknet and not ZK Sync Aera, for example? Ooh, this is controversial. I think, you know, not to pick a side in the ZK wars, I actually think the Starknet community is like one of the most open-minded people and one of the most kind of tech-forward people. They're really just interested to learn more about kind of different technology and so on and explore with it. So I wouldn't even say that I'm necessarily against other ZKs. I think they all are bringing something unique and useful. I think why someone would pick Cairo, the point of Cairo is like it uses Starks, which have, I think, better security properties at scale. Sorry, better performance properties at scale. Obviously, it's somewhat implementation dependent. But we are seeing kind of very significant improvements in sequencer performance. And obviously, I think Stark X provided some good evidence that, Starks can be scaled very well. I think the ergonomics of using Cairo is starting to look a lot, nicer as a high-level language than what we have in Solidity. I think we have to kind of, I think it's probably a lot more difficult language to code right now in terms of we don't have all these security practices established and so on. But I see the potential in terms of the syntax and so on of having a Rust style language that is not as bloated as something like Solana's Rust or Anchor, right, which are much more complicated to work with. So I think those are just a couple of reasons. Community is great. You can get support for your application being developed, or people are a lot more experimentative. I think in kind of the Starknet world, people just have crazy ideas. They're not afraid to push them forward. They're building all sorts of crazy games and DeFi applications and all sorts of infrastructure projects. In open source and in collaboration in Telegram groups. So I think it's just, if that appeals to you, then I think Starknet's a good place. Cool, yeah, thanks Nikki for these questions. Yeah, I think we can wrap here. If there's no more questions or if people want to ask with audio as well, then feel free to.
Thank you, Peter, for this excellent presentation and for answering all the questions we had in the audience. So we are past over time. Unless there is a pressing question, we should be wrapping this up. So let's give folks 5 seconds to unmute yourself and ask a question. Otherwise, 3, 2, and it's a wrap up. Peter, once again, thank you very much for coming.
Thanks everyone, and thanks for everyone who helped with the presentation. And if you have more questions, just reach out to me. Don't hesitate. This is really fun.
Yep. Have a great day. Bye.
Thanks.